Big deal. My IQ is 280.
Stephen Hawking, the world's smartest man.
P3. Topic 5. Lesson 6. Televisions. By the end of this lesson, you should be able to describe the use of electron beams in television picture tubes and computer monitors. An oscilloscope bends an electron beam using charge deflection plates, but in a television tube electromagnets deflect the electrons. The evacuated cathode ray tube, CRT, of a color television is more complex than that of an oscilloscope. In an oscilloscope, the electrons form a single repeating line on the screen to create the image. In a television, the electromagnets deflect the electrons in zigzags across and down the screen, making 625 horizontal lines before returning to the start. The electron beam scans the whole screen every 1/25th of a second. The picture consists of 3 separate dots, or pixels, of color which your brain assembles into a meaningful picture. To see what is happening, look at the blown-up image in this photograph as you move further away. In color televisions, there are 3 electron guns, one for each primary color: red, blue, and green. The television screen is coated with dots of 3 different types of phosphor, one for each color. A phosphor is a material that emits visible light when exposed to radiation. When electrons hit these phosphors, they emit either red, green, or blue light. Before the electron beams hit the phosphors, they pass through a shadow mask. The shadow mask ensures that each electron gun only hits one color type of phosphor. The mixture of light from neighboring dots gives the illusion of different colors of different intensities. For example, if mostly red phosphors are hit, we see red light. If equal amounts of red and green phosphors are hit, we see yellow. To vary the brightness, the number of electrons emitted by the electron guns keeps changing. For example, if there are more electrons, the image is brighter. The beams move rapidly across and down the screen, giving different colors and brightnesses and creating the illusion of a moving picture. Your brain cannot distinguish more than 25 pictures each second, but to avoid flicker, the electron beam traces out alternate lines. In the first 1/50th of a second, voltages to the electromagnets move the odd-numbered lines across the screen. The even-numbered lines can cross in the next 1/50th of a second. The graphs show the voltages VA and VB applied to the electromagnets. One voltage rapidly moves the electron beam down the screen. The other forces the electrons to scan back and forth across the screen. If you're looking for trouble, you've found it.
Yeah, just try me, you. Oh!